Hello everyone. Today we're going to be going over the USNCO Nationals 2025 exam part 1. So this is the first video on this channel. So this is mainly USNCO Chemistry Olympiad channel. So as of now at least. So let's see how this goes. Okay. So right now, right? So we have the first 10 questions, not too bad. So the first question says adipic acid is prepared by the partial oxidation of cyclohexane according to the following balanced reaction. Okay. So a sample of 25 grams reacts with excess oxygen to give 33.5 grams of adipic acid. Okay. So we got to do stoichiometry here, right? Yield is actual over theoretical. So actual right here. This is your actual, and your theoretical is what you're going to calculate with stoichiometry. So we're going to do some real quick stoichiometry here. So 25 grams of cyclohexane. Shoot, okay, 25 grams, right? And that is, you divide that by 84.16, right? Be really careful with your molar masses. These can trip you up. Well, at least they trip me up sometimes. So 25 over 84.16, and you're going to multiply that by a factor. So this is the number of moles of your cyclohexane, and there's, for every 2 moles of cyclohexane, there's 2 moles of adipic acid, so the same number of moles. So that's just 1, so 2 over 2. You don't really need to write like 2 moles, 2 moles, blah, blah, blah. This is 2. So this is the number of moles. Now you're going to multiply by the molar mass of adipic acid, which is 146.15. So when you do this, right, you're going to get, in your calculator, 25 over 84.16 times 146.15, 43.4, and you're going to do 33.5 over 43.4. So you get 77.2. So that's the answer. All right, perfect. So next, this is an interesting question because the second half is a little difficult, but it's a simple knowledge base. At least that's how I figured it out. So basically, you got 1 gram of CO2 heated under a vacuum. It forms 0.630 grams of an oxide of cobalt. So sample is supposed to air, forms a second oxide. So first you got, you know what? Alright, so CO3, right, it's going to go to COXOY, right? And this is pretty obvious because you're removing CO2 when you're heating it, right? I mean, this is very stock. You got compound with carbonate, you're heating it or you're doing something to it, and you get a product, the CO2 is gone. So it's just going to be COO, so that's your first one. So we got C and Dr out. Forms a second oxide of cobalt after it's exposed to air. Okay. So here's the deal, right? First off, if you're just doing this descriptively and not mathematically, you're going to know that when you do this and you expose it to air, well, what's going to happen is it's going to form a cobalt oxide that the cobalt has a mixed transition state, oxidation state, transition metal oxidation state. So let me explain. This sounds confusing. So oxides of transition metals, right? They're going to have the transition metal will have a fractional oxidation state. So it's a common motif, right? You have Fe2O3, right? That's not 1, but Fe3O4 is 1. So you got to memorize your oxidation states and stuff, right? Because if you figure this out, this is 8 over 3. If you do CO3O4, it's the same thing, 3, 4, right? So how I figured this out was, okay, it's A or B, and it has to be the mixed oxidation state because this is +3. Now, if you want to use the math here, you have 1 gram sample, 0.630 grams of an oxide of cobalt, right? So you can figure this out, right? Um, you figured out that the CO2 was 0.370 grams. Second oxide. Now, the math to calculate the second oxide, I couldn't really figure it out. You have to do this. You have to use this kind of knowledge. So, yeah. But for the first part, you could just find the moles and just figure out the molar mass. Use the inverse relationship. So, this is going to be B. All right. Yeah, I didn't really like this section of the test, but okay. Um, yeah. So basically, key knowledge here: oxides of transition metals. The oxidation state will be fractional or mixed. Like 8/3 is 2 threes and 1 2. All right. This is kind of interesting. Complete combustion of a 1.0 gram sample gives this. Okay, so combustion really helpful. The trick is to know, right, that your CO2 moles is the moles of your carbon because that's the only occurrence of carbon, other occurrence of carbon, right? So basically, um, right, you see this, you're gonna have some kind of relationship between O and N, but you can't really figure out O and N. So here's what I mean, right? Mole CO2 equals mole C, so you're gonna do 1.831 over 44.01. That gives you your mole of carbon. Perfect. And now your mole of hydrogen. Be careful here because you're going to do 0.750 over 18.02. And you're going to multiply this by 2 because there's 2 moles of hydrogen in 1 water. So you have to multiply that by 2. So we have 0.0416. So let me write this down. Okay, perfect. So pretty simple so far. All right, pretty straightforward. Now you have to figure this out because it's a 1 gram sample. So you're going to have this number of moles of C, this number of moles of H. And basically from there, you have to be smart about the oxygen and the nitrogen. This is different because there's extra nitrogen, right? So we're going to have to plug in the answers. 1 gram of A. Let's see what happens. The molar mass is 12 times 3, plus 6, plus 14, plus 16. 1 over 72. Okay, we get 0.013 moles C, right? Okay, 138, right? Now we're going to multiply that by 3. We get 0.0416, simple calculation. And multiply by 6, 138 mole H times 6. So this A works, right? And right off the bat, B and D can be crossed out. So it's either A or C. So B is being crossed out. So it's a molecular formula. B doesn't work. So it's either A or C. Molecular formula. I have no other calculations that I can use to figure out whether it's A or C. But because it says molecular formula, I'm going to say that it's C. And that is the correct answer. Alright. So, yeah, okay. Simple, simple. Alright. Okay, this is a nice question. Um, like this one actually. So, for this, 10 milliliters of 0.1 molar CaCl2 is mixed with 10 milliliters of, so you want to know the moles, right? So 0.01 times 0.1, 0.001 moles CaCl2, and 0. So this is 0.005. Okay, now Very stock, AgCl, right? What is the concentration of chloride ion in the final solution? So right now it looks like it's going to be 0.002 or something, right? But the reaction is, right, AgCl to AgCl and okay. CaCl2 plus 2AgNO3 is going to give 2AgCl. The rest doesn't matter because it just doesn't matter. It's going to be split to ions. Okay. So perfect, right? Now we got to be careful here. Why? Well, the thing is, this is a precipitate, so we're actually going to have to subtract for ions, right? Because if you think about it, right? Have the test with me right here. You're gonna have to subtract moles that you get from the precipitate. So this is because AgCl is a very common precipitate. You should definitely know that. You have AgI, AgCl, AgBr, but AgF is not. So it just follows that, right? You're gonna need to know that basically, if you have 0.0005 mole of Ag and you're gonna have to do some kind of analysis here where basically you have to find the total concentration of the chloride ion and subtract the concentration of the chloride ion in this AgCl. So what's the concentration of chloride ion at the beginning? So so you do the subtraction, 0.002 minus 0.0005, right? So 0.0015 moles, you get that. And basically you're going to divide that by 20 milliliters because that's how concentration works. Total moles over total milliliters, total volume, right? So 0.0015 over 0.02. So you're gonna get 0.0075. 0.075. Nice. So yeah, pretty interesting question. Intuitive. All right. Next, this is probably gonna be the slowest. Okay. A metal sulfate decahydrate contains 31.48% water by mass. Okay. Now, this question can take a lot of time or little time, right? So let's see what's going on. MSO4, MX, SO4, Y. Now, M is going to be 2, and SO4 is going to be Y, but be careful, right? Sometimes, if they're both even, they're going to cancel out, so be wary of that. Okay? So, dot, I don't know, decahydrate, so 10H2O. So what you're going to do is, total amount of H2O is 31.48% of the whole thing. Okay. So first you're going to have to think about it like this, right? You're going to have to do 10 times 18, right? 18.02, whatever, over the whole thing. So 180 plus, it's going to get complicated here, right? 2 times M and plus Y times SO4. So we're going to do something called casework, right? Nice solid casework. So when SO4 is 1, what option here works? Na. So when Y is 1, Na, you do the molar mass calculations, 180 over 180 plus Na times 2. plus SO4 does not work. Skip CR. RH, I'm assuming it's going to be plus 3 because it's in group 9. So try that. It doesn't work. AU is plus 1 or plus 3. Doesn't work. So CR works. And CR has 3 main oxidation states, 2 plus, 3 plus, and 6 plus. Alright, perfect. So yeah. Alright, halfway done. Okay. Right off the bat here, you can tell that neither of these are correct because of two simple reasons. First one, this is molality, so 1 is incorrect because this is about mole per liter. Now you might think, right, 1 liter is 1 kilogram of water, roughly, by density, right? But remember that you're adding it first, then adding enough water to dissolve it to reach that mark on the flask, so you're going to have to add less than 1 liter. So 1 is wrong immediately. Perfect. And then 2. Alright. It cannot be that simple on a USNCO Nationals Part 1 exam, right? So you got to think about it like this. Why could 2 be wrong, right? It makes perfect sense. Well, let's write out this reaction, right? NaOH plus HC2. Okay. HCH3. Yeah. Okay. So this is acetic acid. That's how I memorize it. So it's more like the H. Yeah. Okay. So you're gonna have H2O and Na. Sodium. Yeah, you're gonna form sodium acetate. So I think this is the formula. Hopefully, I'm not wrong. Yeah. Yeah, I think this is right. Okay. So right, what happens here? Basically, you might think, right, that whoa, it should be 1 mole of this and 1 mole of this. Stoichiometrically, 1 mole of this, and you have 1 kilogram ionized water. However, this is a very strong exothermic reaction. Water has a very low enthalpy of formation. It's very negative, meaning it's very stable and favored. Molecules that have high enthalpies of formation, highly positive, these are going to be the molecules like fused rings, unfavorable products that are very unstable. So what does this all mean? Well, if H2O has a super low, super negative enthalpy formation, this is going to be an exothermic reaction. So we're releasing heat, negative, I don't know how to do delta H, whatever. Right? So what happens to this energy that is released, this heat? Well, it's going to evaporate some of this water, believe it or not. And it's going to decrease the amount of water you have, so you're not actually going to have 1 mole, whatever, of water. 1 mole of your compound. You're not actually going to have that. You're going to have a little less. So that is why this is wrong. Yeah. It's not, doesn't have to do with neutralization or anything. Even if you have a weak acid, it can still get neutralized fully. So it's not about acetic acid being weak or anything. All right. This is really easy. White solid is either either sodium carbonate or sodium sulfate. Which procedure will best distinguish between the two? Okay. Now, B is the trap answer. Why? Let's go. Let's look through everything. D, connectivity of solutions. Both of these are soluble. Sodium, any alkali metal compound is going to be soluble, so connectivity won't work here. So that's wrong. D is wrong. Okay. C, potassium bromide. Well, if you write out the reaction, right? Simple reaction mechanism here. NaCO3 plus KBr, NaSO4, and whatever. Forget this. Okay, SO4 and KBr, right? Well, if you look here, you're basically gonna form NaBr, which dissolves, and K anion, right? So these are all gonna dissolve. You're not gonna have a reaction. All right. Now, barium nitrate. So this is about barium, not nitrate. Obviously, solubility. This is called qualitative analysis. Yeah, these show up all the time. Honestly, always about solubility, mostly. So barium CO3 and barium SO4 are insoluble. I would say the latter is slightly more insoluble, but that doesn't really matter. HCl, remember your carbonate, right? Very stock. You have two HCl's. Uh, no. Actually, this is correct. It's just that you're gonna have a ton of HCl's. You're gonna form H2CO3 and NaCl, whatever. This is very stock decomposition reaction. This does not form H and CO3. H and HCO3. It forms H to O and CO2. So this is about the emission of a gas. H2SO4 is not a gas. It is just a strong diprotic acid. So that is why A is correct. Because with the first compound, you're going to form a gas. Perfect. All right. Colorimeter contains 4 LEDs. Which one would give the best results in determining the concentration of the substance that forms blue solution? Very simple, right? Colorimetry. This is all about complementary colors. So basically, you're forming a blue solution. So you're reflecting blue, meaning that you absorb the complementary color. And what's the complementary color to blue? So that would be red. Very simple. I don't know. This is a weird question. I've never seen this on this exam. But yeah, pretty cool. Pretty cool. All right. The student wishes to determine the number of colored dyes present in the ink of a black felt tip paper marker. Which technique would be the most helpful? Okay. Really easy question. Please do not get this wrong, right? Color, you got so many keywords here. Colored dyes, felt tip markers. This is a stock chemistry lab. If you've taken AP Chem, you're gonna know right away this is paper chromatography. I mean, you literally got a marker. You're not gonna use a marker on a gas. You're gonna use it on paper. I mean, it's just common sense. But in all seriousness, you probably want to know that D, ultraviolet visual spectroscopy, excites electrons. It's nothing to do with this stuff. UV, yeah, okay. C is, we're gonna go over that later in later questions. But it's basically NMR, you're determining the structure of compounds. It works by chemical shifts. Gas chromatography, where's the gas here? And A is paper chromatography. It's like basically there's a retention factor, how far each dye travels determines its attraction to the solvent. So if the solvent is water, which is polar, travels farther, it's more polar dye. Right. So yeah, so this is A. Alright, very simple question here as well. So a solution of a metal chloride gives a red flame test. Which metal is it? Simple as that. Let's go through these real quickly. Right off the bat, if you know your flame test stuff, this should not be too difficult. But Na, this is going to be yellow. Okay, Na is yellow. K is lilac. So pinkish purple. I don't know how to describe it. Cu. Well, it depends, right? But I'm assuming they mean Cu2 plus. This is going to be blue green. Sr is red. Sr2 plus is red. So how does the flame test work? Your electrons are being excited and then drop down, and they release a photon of light. And that's the color. So it all depends on the gaps between the energy levels, stuff like that, that determines it. Like Na, K, like everything is different, right? So yeah. All right. So the answer is D. All right. So those are the first 10 questions. Yeah, pretty good. Sounds good. All right. We're gonna keep going to the next in the future videos. All right.